So I put together this show, not with so much how to, but to understand. So most of what I want to do is I don't make any recommendations to anybody in beekeeping. What I do is I'm happy to explain the biology and physics and chemistry and that kind of stuff, and then allow people to make their own management decisions. So I've been keeping bees for a very long time. It used to be much easier. Sears Roebuck, you order your hive, you order your bees, put them in a box, and you could walk away from her 10 years. So you still have a healthy colony of bees there. They would have swarmed every year, but beekeeping was really easy back then. We just coming out of this pandemic from a virus right here. Well, this is in humans. When Varroa arrived, it kicked off a pandemic in the honeybees. And that's the thing to keep in mind is it's a virus issue. And the main virus that's an issue is deformed wing virus. And that normally is a relatively benign virus, and it still is in honeybees. Pretty much every bee in every one of your hives is infected with deformed wing virus, just like all of you all are infected with herpes virus. Most of you with chickenpox virus, you got as a kid. You never get rid of it. It's in your body for the rest of your life. So that's called a latent virus. And normally deformed wing virus is a relatively latent virus. A whole bunch of different strains. There were like 24 different strains kicking around until Varroa arrived. The virus is transmitted transovariously by the queen to the eggs, and then by the nurses to the larvae. So it's there all the time. What happens once Varroa arrived, then it's nature selected for certain variants that could use Varroa efficiently as a vector. So the first time ever, the honeybee, which had just like you guys, in fact, you can do an experiment with me right now. On the count of three, everybody take one deep breath in. 3, 1, 2, 3. Okay, you've all inhaled a whole bunch of virions and a whole bunch of fungi spores and a whole bunch of bacterial spores. Generally, the experiment goes well and nobody dies from them. And the reason is you have immune systems that are adapted for getting exposed that way. The same with the honeybees. What they didn't have is immune system to adapt for getting virions injected directly into the hemolymph. And that's what Varroa does. Very effective vector. It used to be we saw deformed wings pretty quickly. We don't see them as often now. Your colony can die before you see many bees emerging with deformed wings. What you'll see is the pupae starting to die. Here's that one bee with deformed wings, but you start seeing this pupal death. Then you get to what's called parasitic mite syndrome, where the later instar larvae and pupae start dying wholesale. It just looks like there's no pointer for those of you who are looking online. Actually, I could do that. Both of you. Okay, so you start seeing the pupae and late instar larvae dying. It looks like from every disease known, and it's from their immune system being so suppressed that they can get infected by almost anything. And then finally, you get deformed wing virus collapse. And I see this from the beginners every year when they say, "Oh yeah, I got that nuke from you. It's beautiful, did great. August, it was September, it's looking wonderful, full of bees." And then 2 weeks later, all the bees swarmed or absconded or ascended to heaven or whatever the hell. And they're all gone right now. And I say, well, bring me in the combs. And then I point out, look for the little snowflakes at the tops of the ceilings of all the cells. And that's a sign, that's Mite fecal deposits. And if you have a black light flashlight, it's really cool. They do fluoresce under black light, very easy to see. And I said, well, actually, they didn't abscond. What they did is your Varroa management was inadequate. Let's step up the game on that this next year. So for epidemics of pathogens, such as with malaria, you don't necessarily have to control the pathogen itself. You control the vector. So for malaria or dengue or yellow fever, and I've worked in Brazil on this with mosquitoes, is you just control the vector, the mosquitoes. And then if you keep the vector level down, you don't get the epidemic of the pathogen. So this is concepts and Varroa management right here. So the first concept is Varroa management is all about controlling the vector of the viruses that actually do kill the hive. A colony can handle an incredibly high population of mites. You can have a mite on every adult bee in the hive without viruses, treat it, kill them, and the colony will still recover and go through the winter. That's how it was when we first got Varroa. It was just, and there's no way in the world we could do that now because the viruses have evolved. And as a biologist, I've watched these viruses evolve over the years in the bees. So I made a graph here with the mites per 100 bees, or infestation rate here, and that would be the red plot right here, and the red plot right here. And then this would be your deformed wing virus prevalence in the workers, and this would be your paralytic virus prevalence. And you can see they track exactly equally, as long as you keep your infestation rate below about 2. So that'd be 6 mites in a mite wash of a half cup of bees. Viruses are pretty much latent. It's when you get above 6 mites in a mite wash that you start to see effects from the mites. Okay, so first thing for managing the mite is looking at the integrated pest management pyramid. And typically you start with biological resistant stock at the bottom. And I do this at home in my own orchard and garden. I planted 20 years ago a whole bunch of cultivars, different cultivars of table grapes. Some of them year after year had all kinds of mildew problems, and some never did. So I just either dug up or top worked all the stock if possible. And that is our eventual goal, to do this. So I will dive into this just a little bit right here. I'm involved in a selective breeding program for Varroa resistance. We're going into our 8th year right now. The thing to keep in mind is my program is a little bit different than most of the high-tech programs, where they actually tell the bees how to do the job by selecting for a specific trait that they can be measured. What I'm looking at is this concept right here. It's not necessary to kill a single mite to completely control Varroa in your colonies. All you need to do is to cut their success at reproduction in about half, and they'll disappear on their own. That means natural mortality exceeds recruitment. So if I use my Varroa model, it's an online model, this would be your typical buildup. Here's your adult bee population in the hive. This is the number of pupae. This red would be percent of those pupae that are infested by a mite. Once you get about 30% of the pupae infested by a mite, your colony is walking dead. They don't know it yet, but they're going to die. This is at a standard reproductive rate of 1.45 mated emerging daughters from a reproductive cycle of a founder's mite. So a founder's mite enters a cell, on average, non-resistant stock, about 1.5 mated daughters, because non-mated daughters don't count because they can't reproduce, emerge along with most of the foundresses. Some of the foundresses die of old age. If I do exactly the same simulation here, but I have this reproductive rate right here down to 0.725, there's your mite count for the year. Mites cannot build up in the hive. If you take it a little bit less than that, they just disappear to 0. So the point is, you don't have to ever kill a mite. All you got to do is just decrease their rate of reproductive success. So in my selective breeding program, I followed the advice of John Harbaugh and Jeff Harris way back in 1999. Just compare the growth of mite populations in hives. You don't have to ever open the hive to see how they do it. Just do a count on your mite population, which you can do with a mite wash. So I realized we're not going to ever have resistant stock unless the commercial queen producers start producing it. I'm a member of the California Queen Breeders Association. They all go, well, we sell every queen we can produce anyway, so there's no economic incentive for doing this. And they said, well, it's going to be too hard, too much science involved, too much record keeping. So I said, tell you what, guys, let me just walk the walk and see what would happen if you do a traditional selective breeding. So understand that most all cultivars of crops, fruit, vegetables, and strains of livestock were all bred prior to the word genetics ever being invented. You didn't have, these people were not scientists, but they bred all these things by traditional breeding, by simply looking for certain traits and selecting for that. So we just look for mite count in the colonies. Okay, so every spring we make about 3,000 nukes every spring. keep about 2,000 for ourselves, and we'll track about 1,500. We graft from our selected breeder queens, colonies that exhibit mite resistance, starting with a colony 1, queen 0 colony that I found over 7 years ago that never needed a treatment. And spread them out. We have 65 different apiaries around our county. And then we start the Varroa race and let Varroa just start building up. We have to wait. You can't do selective breeding when the average mite count is like 2, because there's not much enough difference from a count of 0. Okay, you have to have a variation. Okay, so we need to let the mites build up to a high enough level that we can select the resistant colonies from the non-resistant colonies. So we started out waiting until so we could select the ones that have mite counts of 0 versus the ones that have mite counts of 15. What's interesting is we don't do this in June anymore. Pretty soon we were having to move to July and then to August. And some of our yards, it was October before any of the colonies in yards had high enough mite counts that we could go higher. So what the boys will do is they'll go out to a yard, they'll wash the first 10 colonies, and they say, Dad, they're all 0s. What should we do? I said, well, you can either wait or you can just pick out 10 really good ones for breeders and then treat all the rest. So we weren't even tracking. We realized this last year, we were treating a whole bunch of colonies that were resistant that didn't need it. So, and here's what we see. So again, our expected rate of mite increase by September, we're usually up to that 50 to 60 mites, and the colony is toast by that time in a mite wash. This would be typical for what we're seeing now in our breeder program. We typically see mite counts of 0 to 1 all through here. If a colony is looking really good, Big will say, well, okay, we'll let it go if it's a count of 1. Sometimes he will, on a really good colony, we'll even let it go to a count of 2, as long as it brings it back down on its own later on. And we take, the first mite wash early on, second wash, third, usually about 4 or 5 over the course of this season. And then we take these 6 after winter, we take the last one, and they still got to be down there, the 0 to 1 count after a full year without treatment, right in the yard with all the rest of the bees and all the mite drift and all that. So with no excuses for them. Oops. And one of the first things I noticed is that, oops, we have a delay here. Many colonies of these. So here's like a early July right here. Ass-kicking colony, beautiful, huge honey producer with a mite count of 2. And the boys go, Dad, it's got a count of 2, but it's really jello colony. And I said, so give it a chance. You're gonna take another wash in a month, no big deal. And sure enough, by August, it took it down to a 1, and by the end of September, when normally the mites are starting to come out of the brood and the counts go up, it had taken it down to 0 on its own. So that's the kind of breeder we're looking for. So we're finding out that if you have a colony collapse with a bunch of mites in the yard, or you have neighbors like that, some of the mite counts will go up in these breeders, and then they'll take them back down on their own. So we've learned to be a little loose on them and let them get by with that. Okay, so now here'd be a typical breeder right here. July count of 1, August count of 1, September count of 2, and then November count, when they shut down brood rearing, all the mice come out of the brood, goes up to 7. So the first couple of years, I would take that out. And then I was over in France talking to John Kiefus. He did coined the bond method, selective breeding, live and let die. He said, oh, don't do that, Randy. Give them a chance till next spring, see if they bring it down. So we started doing that, and sure enough, March, when we started grafting, it had taken it down to a 1 again by itself. Of course, there's more brood then, so the mites are going into there. So we give them a break for the November count. The colonies we really like to breed off have counts like this. 0s are heroes, where they're just 0 count. We know there's mites in those hives, but you can do a whole bunch of mite washes, and we never pick up a mite in statistically, a count of 0 and 1 are the same, because you're only taking a 300 bee sample. But we love these ones that are just 0, 0, 0, 0, 0s. The other thing is that they're often the strongest and most productive colonies in the yard, because they don't have the virus issues going on. So we go out and when you pop the lid off and you go, wow, wall to one, and you go, well, this is going to be a breeder, I'll bet. And sure enough, you do the mite wash, and they just do really, really well. The other misconception people have is by association with Afronized bees that they got to be pissy bees, defensive bees. So in August, when I'm doing mite washes, it's pretty hot and I don't wear a whole lot of protective gear. I may be doing 50 mite washes in an bag off. They're out of the program if they're defensive. So we only breed for very gentle stock. We've been making progress. So this would be red would be the non-resistant colonies percent in our operation, and the green would be the percent that exhibit resistance. And it starts off very slow, one colony out of 1,500. So that's a fraction of 1%. And it's increased that we're now coming up to this level here. So this will be the first year that over 50% of our drone pool will come from resistant colonies. And actually, well, let me go on to this here. I don't know if I have this. Oh, I didn't put it in. Okay, that's another slideshow. So the thing to understand is the genetics of the drones reflect that of their grandparents 2 years previous, okay? Because it can only come from the mother, and the mother's genes come from her mother and father. So that's 2 generations back. So right here, where we had 10% of our colonies exhibiting resistance, you're meeting the drones that were way back here with only 5%. So you're not going to get very good matings. This year, Ray Oliveras approached me and my sons and said, Randy, because he's been brokering some of our bees into almonds. He goes, your bees are looking really good in almonds every year, Randy. And they're exhibiting some resistance. Would you mind if I produce some of your queens? And I said, no, you can't control the matings. So he goes, well, actually, he pays for rights to a 25,000 acre ranch on the other side of Orland. And I checked it out on GPS, and he says, you can have it for your drone mothers. So we put 400 drone mother colonies, all of which were resistant. And he's got a dozen of we're swapping breeders with him. So he's grafting off of those breeders and then mating them in that yard. So we may take a jump up. We're hoping we may be past this tip point now and really, so we don't claim resistance yet. Okay, you got about 50% chance, but we are hoping with this mating, we maybe get over the edge. And again, I'm not doing this to develop a stock. I'm doing this as a demonstration project for the queen producers. People say, well, why aren't you doing marker-assisted selection? Why aren't you doing single drone matings or instrumental insemination? I said, because I'm not doing it to do it the fastest way. I'm doing it the easiest, simplest way that any queen producer can do it. So I'm doing this, and I'm right now we use these little battery-powered mechanical agitators, which allow you to do all these mite washes. And we're building a batch 24 right now because we got 2 batches going to Spain, 1 batch going to England, another batch going to other country. So worldwide, this is being followed closely, our rate of success with this simple method. So it's very exciting. I would love before I died to be able to have bees that you don't have to think about Varroa anymore. Yeah. So someday it's going to be a minor problem. There's already some countries, Cuba and South Africa, they don't even talk about Varroa. Their bees have it, but it's not considered an issue worth treatment. And that's the way it should be. I mean, it's been over 30 years here in the United States. We're still at square one. That's ridiculous. What's that? Yeah, because the government would not allow them to use miticides. So natural selection in about 6 years, well, it's the live and let die method. The only bees that are alive after that time are those that exhibit resistance. And I got a whole other PowerPoint just on the selective breeding. Okay, the thing is, when I saw Queen Zero, I realized we don't have to invent anything new. We've already got genetic combinations in our operation that laugh at Varroa. It's just at a low prevalence. So now at this point, it was just a matter of selective breeding to increase the percentage of colonies that already had that trait. You follow me? Okay. Oh, the question is, going to be in Cuba that the mites have a disease? That does not appear to be the case. Same in South Africa. It's just simply the bees suppress the amount of reproduction, just like Apis cerana does, the native host of Varroa. They don't count on the disease for Varroa. They simply decrease the rate of reproduction. Oh, it's a okay.
Can you
figure out what's
can you
happening.
talk?
Okay, so
Sorry.
second thing is to understand Varroa population increase. Anytime you see sealed brood, the other name for this is Varroa food. This is where mites reproduce. If there's no sealed brood, they cannot reproduce. So they got sealed brood, assume that mites are reproducing. And the more sealed brood in the colony, the faster they reproduce. So your most productive colonies are with the most brood are going to be the ones that produce the most Varroa mites. What happens over the course of the year, and I have this on my model you can put in, you can type in for wherever you live, how many months they have brood in the colony. So up in Canada, you may say they have 5 months with brood. If you live in Southern California, you say they got 12 months with brood. So if they have 6 months of brood, then my population will increase at about this rate. You'll be up about, if you start with 1 mite, you'll have 50 mites. If you start with 100 mites, you're going to have 5,000 mites after 6 months. And then when there's no brood, you have a slower decrease just due to natural attrition. So understand when there's brood, mites increase. When there's no brood, the mites will decrease on their own. And the number of months is the critical thing. So 6 months of brood, they only get to 50 times. You got 8 months, now you're up to 200 times. 10 months of brood, you're up to 700 times. If you're in Southern California, they're off the chart due to continuous brood rearing. The other thing is, as climate warms, we have a shorter brood break. So back in the day, all my colonies shut down brood rearing November 1st, okay? Which means there's no mite reproduction going on until sometime in January. Nowadays, we may only get 2 weeks without brood rearing, which means Varroa is going to be more difficult to control. And if you look at the weather, so like, oh gosh, right here. So this would be a very cold winter right here. This would be a very warm winter. So this winter, you have a long break. Beekeeping is going to be easy for Varroa management because you had a very long cold winter and there's no mite reproduction. This year right here, the beekeepers are going to say, wow, Varroa wasn't a problem last year. Let me keep doing the same thing I did. But this year, Varroa gets head start because they have a short winter and everybody gets wiped out. And this we can predict years when commercial beekeepers are going to lose a lot of mites. If you have a very warm winter across the United States, then you're going to have more Varroa problems. Yeah. Why don't we treat our breeder colonies? Because we wouldn't know if they were resistant. Yeah, so they don't get any treatment. We haven't used a synthetic miticide since the year 2001. So we've been 23 years without using a synthetic miticide. We use only just oxalic acid, Thymol, and Formic acid for treatments. So you can use my online model to create your own management strategy. So you can figure out the number of treatments that you need. Again, adult bees up here. Adult bees up here. Then pupae is the orange. This is your mite wash count right here, alcohol wash or detergent water wash, and your infested pupae. This also shows your percent of mites that would be expected to be in the brood at any time down along the bottom right here. So very high percentage in the springtime and 50 to 60% most of the rest of the year in the brood. Okay, and here what I did is I put in 2 treatments right here and keep that mite count down very low. And again, this is the model. You can put in whatever area you live. Develop a online model use on your cell phone. Send her a donation. She worked on this for 2 years to come up with that, and not quite as much information available or customizable as my computer model, but can work for you. So again, the number of months the colonies brood, that tells you how much reproduction. So in areas with a winter brood break, so see where there's no brood here and no brood here, you can maybe get by with just 2 treatments a year. If you live in the Mediterranean areas, and you guys are pretty close to that right here. You're gonna need a minimum of 3 treatments a year. And for California, almond pollinator, when you have this big spike in population in February, it's going to take a minimum of 4 treatments a year in a non-resistant colony to keep the mites down, to keep your at this low count so your colonies are healthy. The main thing is starting off with make sure you get down close to 0 in the springtime. Also understand it's much easier to control Varroa if you keep the count down rather than trying to bring it down because of exponential growth, which means on any time interval, it's exponential from your starting mite count. So exponential increase from 1 is very little. Exponential increase from 100 is very, very high. So what I made is a graph right here. So you can, this would be your number of months. So we're going to start at over here, the red, bright red is starting with 150 mites in the hive. Down here, you're starting with only 10 mites. I did put immigration from outside into the hive into here, but look at the difference right here. For if you start off with only 10 mites in a hive, you never get up to, as long as you're below a couple thousand mites in a hive, you don't have an effect. So you have 7 months. It's not a problem. You start off with 150 mites in the hive, and you're starting to get up there into the problem in just a few months. So the main thing is don't let them, the more mites in the hive, the more rapid the rate of increase. So try to keep them down all season long and keep these very low infestation rates all across the season. It may jump up a little bit in November, but you can always do a winter cleanup as soon as they go broodless with an oxalic acid dribble. Yeah. Okay, that's not weakness. That's non-Varroa resistant. Don't add other things to that. Okay. Okay. So yeah, that's what we've been doing all along. But unless you're in a selective breeding program, it doesn't make any difference because you're mating out your queens to all your neighbors. So you're wasting your time, unfortunately. Yeah. Uh-huh. Okay, she's talking about drones and making mites availability. That's some interesting research from Dr. Zach Lamas. Excuse me. I followed up on that and I published research on that. And what we found is that if you go into colonies and you just pick off drones and then do mite washes off the workers, we averaged about 7 times as high mite infestation rate on the drones as on the workers. So on a mite wash, you don't want to get a bunch of drones in your mite wash because it'll give you an abnormally high level. So mites do reproduce more effectively in drone brood, but you're not going to be able to do much about drone brood unless you're doing drone trapping in your colony, which gets kind of old. Yeah, any colony is going to try to produce about 5% drone brood, and you can either control it or not. We run a drone frame in every. I just said we leave it in there. Yeah, we don't take them out. Okay, unless we see a colony that is a high mite level, then we want to eliminate those drones. But generally, we don't do it. We just leave in every colony. We just leave a drone frame in. That way, we control where the drone brood is in the colony, because we sell 1,000 nukes a year. People want frames that don't have a bunch of drone comb in them, so we get better looking frames if we just give them a place to make the drone brood. So our resistant queens, they're resistant with a drone comb, with drones all season long. Yeah. It's okay, you said? We ourselves do not cut out the drone cells normally. Okay, a cutout of drone cells takes out on average about 14% of the mites. Okay, it's about a relatively small reduction. If you do it regularly, now in California, they don't usually rear drones for that long. We typically shut down drone rearing during the summer. areas where they rear drones all season long, it would be more efficacious. There's another guy I'm corresponding with in Sweden. He's came up with an invention. He takes his drone frames and divides it into 3 parts, and he cuts out 1 part every week. That way, you're always because if you wait for the whole thing to fill up, that means all the ones that are sealed can no longer have incoming mites. So by cutting out 1/3 of that drone frame every week, he's trapping incoming mites continually. He doesn't have any hard data. I'm trying to convince him to run a trial. If anybody wants to run a trial with that, let me know. I'll give you a protocol of compare the efficacy of a triple drone frame as opposed to a 1 drone frame cut out. Yeah. You can overtreat because all treatments have some effect on the bees. Some of them have very little effect, but anytime you put something in, you're trying to you have a selectivity ratio, which means that that's your margin of safety. So like with the fluvalinate treatments, the selectivity ratio is about 1,500, which means it took 1,500 times as much fluvalinate to kill a bee as it did to kill a mite. With our organic treatments, the Formic and the Thymol and stuff, it's more about a selectivity ratio of 3. So you can have a slight, or depending how much you put in, an adverse impact. So you try to balance out your treatment. And why not treat all your hives? Go for it. I told you, I don't make recommendations. Yeah, that's fine. What we find in our operation is my sons who complained first about doing mite washes in the spring, now they say, how soon can we start? Because it pays for itself. The number of hives that we don't have to treat, it's cheaper for us to do a mite wash, way cheaper than it is to put in an off-the-shelf treatment. So if you're spending $6 for a treatment, it costs us about $1.50 to do a mite wash. So so now they're eager to do that because it saves them a ton of money by doing mite washes and avoiding unnecessary treatments. Okay, does that make sense? Okay. Also, colonies that keep with low mite counts are more productive. They make more honey, and we see that all the time in our yards. So you get your most bang for the buck by controlling the mites early in the season. And the reason is that the mites spend 12 days in the sealed brood. That's called the post-capping period. They reproduce during that time. Then the young female mites come out. They need to do 2 things. They need to wait for the sperm to mature before they can reproduce. And they need to take this is new information, they need to feed on, if they only feed on the hemolymph of the pupae, they don't have all the proteins they need to make eggs. They need to feed on the fat bodies of an adult worker bee. That combination of proteins then allows them to lay eggs. I don't think this has even been published yet. Fascinating stuff. So you have what's called the dispersal phase, or inappropriate. They're not feeding on the host. Dispersal phase, they are feeding on the host. So technically, Varroa have a dispersal phase, not a phoretic phase. Anyway, that phoretic phase, when you have a very high ratio of brood to adult bees, is very short. It's very easy for the mites to find a way in. Maybe it's going to be about 5 days. During the summer, when you have a much higher ratio of adult bees to brood, it may be 30 days. So you have a longer phoretic phase. So the shortest phoretic or dispersal phase is during swarm season. And when I plot out the rate of reproductive success of mites from January to January, so this is your instantaneous rate of increase, much highest right at swarming season, because you have your highest ratio of brood to adult bees at that time and your most amount of drones in the colony. So the key thing is to control mites, get them down before they're at their highest rate of reproduction. Yeah. A lot of people, what? Yeah. Yeah, so when you get a package of bees, when you put them in, the earliest you could possibly get a sealed brood cell would be 8 days. It's usually maybe about 10 days. So anytime that first week you do an oxalic acid dribble, you can eliminate almost all the mites. I just got a call from Oliveris. They're sending out huge order of packages and asked me for the right formulation. They're going to spray the oxalic on the packages themselves to pretty much eliminate the mites. So you want to nip the infestation in the bud and keep your mite level down throughout the season. So a reactive beekeeper waits till he sees high mite levels, then he treats, whereas a proactive beekeeper gets them down in the springtime early on and keeps that mite level low, and you might be able to get by with just fewer treatments. The lower you get the mite level early coming out of winter, the fewer treatments you'll need during the year. And this is Russ Highcomb, a friend of mine, Highcomb's honeybees, and he was quoted this saying, "I'm not treating because I have high levels of mites. I'm treating because I don't want high levels of mites." So he's a proactive beekeeper. Okay, now there are other things besides resistant stock. This is a physical, mechanical, or biotechnical methods, such as, and I'll go through them quickly because the worst thing that ever happened to beekeepers was the internet. Because there's no editor on the internet, so everything goes out there. And small cell, Dee Leslie was the big promoter of this. I took a photograph for her when I visited her years ago, because she noticed that the bees where she lived in Arizona started changing and building small cells, and they were somewhat resistant to mites. Anybody else would have said, "Dee, you're keeping Afronized bees. They're invading," but she wouldn't refuse to call them Afronized bees. She said, "They're small bees," okay? But anybody else would say, "These are Afronized bees." It wasn't the small cell, it was the change in stock. But the small cell, many commercial guys tried it. It just didn't do it. Allowing colonies to swarm. No, that only reduces the mite population by about 30%. At least 70% of the mites in the parent colony with fewer bees. So it actually increases the mite problem for the parent colony. And it also sends out mites colonies out in the landscape for everybody else to share the mites. Screen bottom boards, maybe a slight benefit. We put 500 of them in many years ago, and we're phasing them all out, other than for research. We just did not see a benefit to those. Drone trapping, it can help a bit. You have to do a lot of it. Generally, it's not enough on its own. I probably dusted more powder sugar than any human being on Earth in experimenting with this, and it does work, but you have to do it like once a week. And most beekeepers get tired of doing it once a week. So it can work in it has to be a dry environment, but it's a lot of work. Thermal treatment, yeah. It gets on their foot. And you can use any kind of dust, but powdered sugar does not harm the bees. Yeah. Okay. I don't give advice. We did not find it to be of enough benefit. Yeah, we found there's some adverse effects to it. If you're an almond pollinator, the bees don't want to be able to brood down to the bottom, so your colonies are smaller going to almonds. So there were some negative effects, not enough positive effects to make it worthwhile for us. Okay. Thermal treatment, it can work, but when I tested it out, I did not see good kill of the mites when I dissected the brood afterwards. And they still remained reproductive. So you have thermal treatment, you have to pull all the combs out of the hive to individually treat them. So again, whatever is your joy, you do that. Okay. My joy is spend the least amount of time doing expensive things to do in the bees and make it as simple as possible. So we use the minimum equipment. We have no gadgets, no gizmos. We use the same exact treatment that they used in 1850s, blanks off the equipment, nothing special in our operation. But that's my choice. If you want all the whistles and bells, go for it. The one thing that we found is really switched our whole Varroa management is we split every one of our colonies in the springtime, coming back from almonds, into nukes, starting with a queen cell, and it created an induced brood break. And I saw my website showing what happens. You create before the new queen here, the larvae have to be 8 days old before any mite can enter it. So that means that you have this very narrow window of opportunity right about day 19, when there's almost no chance of a mite finding a brood cell. So we start all our nukes, and then depending on the temperature, day 18 or 19, we give them an oxalic acid dribble and start all of our colonies every spring with low mite counts. And you can combine those nukes back together. You don't have to increase your number of colonies, okay? So you can requeen your colonies and take care of the mites. Yeah. No, we do not treat our resistant colonies if we've identified them as being resistant. We do not treat our resistant colonies if we've identified them as being resistant. Does anybody, any misunderstanding still? Okay. So yeah, now here's our tip for you. Oxalic acid dribble. I don't know if you ever tried using a syringe, but it's a pain in the butt. Get a 250 milliliter wash bottle, lab wash bottle, or they call them tattoo wash bottles. You cut 1 millimeter, about a 16th of an inch off the tip, and that hole size is just right that it puts out 5 milliliters per second. So you just go chimpanzee 1, chimpanzee 2, chimpanzee 3, chimpanzee 4. Create a 10 frame colony in 10 seconds. Really easy. This is just figured this out last year, and they work so good. I gave them out to all the members of our club. Now, you can also, if you are a recreational beekeeper with a few hives, simply do brood separation. Just separate out, if a colony's just before swarm season, you can separate out all the combs with sealed brood, separate from any other comb. So it can be honey, larvae, anything else. And this is on my first year beekeeping. I'm not going to go into depth on this, but you simply, on the original stand, you leave the old queen and no sealed brood in that one. Give them an oxalic acid treatment right then. You get almost no mites left. You start the other one with a queen cell, a swarm cell that's in there, or a raised or purchased queen cell. 18 days later, you hit them with oxalic acid. So now you have, take this colony that's about to swarm. It won't swarm because you split it. You're raising a new queen for a replacement queen. You're controlling all the spouse says, I thought this was going to be a hobby. You got 37 hives in the backyard. You say you're going to double them by splitting them. You just put them back together at the honey flow. Okay. Now you have super strong colony. It's been requeened and free of mite, ready to make a bunch of honey. Okay. So kill four birds with one stone. Okay. Monitoring the mite level. Just don't, I suggest you just don't take your eyes off Varroa. I have lots of commercial beekeepers visit me because they're curious. We go out and we start doing mite watches, and they go, oh my God, I have been blind. Every single one just goes, I have been so blind. If you're not doing mite wash on your hives. So it really lets you see what is happening with the mites. You can't tell by visual inspection. By the time you start seeing mites on the backs of bees, it's too late. That's too high a level. And about half the mites generally are hiding in the brood. And if you look right down here, so right at swarm season, we got 78% of the mites hiding in the brood. That's only 20% of the mites are going to be on the adult bees. So it's a much higher infestation rate than you would imagine. So you have to interpret the mite wash relative to the time of season and how much brood there is. Sticky board counts can work. They give a rough estimate, but they're time consuming and erratic from day to day. They can vary by a factor of 3 day to day. The sugar rule, I've published data on this where I've done it by the protocol with a full 60 seconds of hard shake. Sometimes get as much as only 50% recovery of the mites, even if properly done. So if your treatment threshold is very low, sugar roll may miss it, may be getting zeros when you actually have more mites. We do scientific data, so we have to have much more accurate. We found the most accurate way is to do a mite wash of a half cup of bees, either in high proof alcohol, 90% alcohol, not 70%. You get much better mite recovery with 90% alcohol, or Dawn detergent. We shake them into an 18-quart cup, and we let the older bees, hang on a second. The older bees will immediately fly off, leaving behind the younger bees. The younger bees have a higher mite infestation rate than the older bees, so it's more representative infestation rate. And then once the adult bees fly off, the young bees that are left, they just spread out into a single layer. It's easy to spot the queen if you miss the queen. Yeah. Dawn detergent. Yeah, Dawn Ultra. That's all we use anymore. We don't use alcohol anymore. Very good recovery. The Dawn detergent, you need to let the bees sit for 1 full minute before you start the swirl to drop the mites down. It takes about a minute for the mites to release off the bees. And then we scoop up half cup of bees, level it off. I've done this tens of thousands of times. I've never once been stung on the finger. Okay, so it's only young bees. They don't sting you as long as you don't press them. You just brush them off, no problem. And then dump them into the cup. And in Dawn, this is your 10 seconds to 20, 30, 40, 50 across the bottom. And you can see it takes about 60 seconds before most of the mites drop off. Then you start a agitation. Even 30 seconds of agitation, then you're going to have almost 100% recovery. You want to just gently swirl that cup for at least 30 seconds. And let's try. Just enough motion that you can see the bees at the bottom of the cup swirling slightly. I'm going to be publishing a new method of making these cups really soon. If you remind me when I'm done, I'll show you a preview of it. But a new method makes them really simple. You can make them yourself. Oh, maybe I'd have it here. Oh, I added it. Iron, you just punch holes in there, and we 25 holes makes this beautiful cup. Takes you about a minute and a half to do this. One very quick pass with a cigarette lighter, any threads are gone. And then you drop the perforated cup into the solid cup. There your agitation, all the mice drop down in that little space underneath. And then because there's foam on the top, you pull the inner cup out with the bees and toss the bees in the compost. And then you view with a 10x magnifying mirror underneath, and it makes it super easy to count the mice accurately. Yeah. One tablespoon per half gallon of Dawn Ultra. So 4 millimeter soldering iron. You go chink, chink, chink. I'll be publishing the pattern to put them in easy. Melt off any threads so the mice don't hang up on them. And then we actually make cup holders. You just drop it in here. They'll hold the mirror, so very quickly you can count our mice. Because we may be doing 200 mite washes in the afternoon. Okay, so we've got a system to do it quick. And then we're cheapskates, of course, so we strain and reuse the detergent. Okay, just put it through a tea strainer. Springtime, we don't want to see a count above 2 mites. We want to see it like maybe 1. This time of year, we'll get our treatment threshold for us is 6 at any time during the summer, which usually starts to non-resistant colonies. If we've treated them with the induced brood break in the springtime, that usually occurs about the 1st of July in our area. Understand that bees drift tremendously from hive to hive in neighborhoods. And when I've got a lot of data, I'll be publishing a bunch more data soon on mite drift on drifting bees. So mites ride on drifting bees. And you can check to see so this would be our daily mite counts coming in I should say usually twice a week. So this would be every 3 days. So 5 mites came in at this during that time 3-day period. This one we had over 20 mites come in 3-day period in this colony. And you validate it by you look if it's raining or windy and there's no bees flying, no mites come in. So it tells me that I'm validating that it's accurate. This is showing incoming mites from outside hives. We can talk about that later. Just remind me. It's a special setup. And what we find is you can get in any yard 2 hives side by side. One will be a bee magnet, and other ones are not. Some will have high mite this is cumulative over the season, over the 2 months of mites. Maybe got like 500 mites. Other ones sitting right side by side will be none. And they can be well away from the mite donor colonies. My guess is it's probably odor. That'd be my guess, not so an untested theory. But we just see, you can have a line of hives side by side, and one will have a super low mite count day after day after day. The other one will have it. When we have a group of hives and we have the mite donor colonies, the collapsing colonies on one side, the first hives on the outer perimeter of the yard will tend to get higher counts than the ones in the middle. Okay, so it has to do with the drifting of bees. Not the mice don't choose the colony, the drifting bees choose the colony. Okay. Then we have what we call mite disseminators. So when we first started doing these high level mite washes, we found out 200 hives we sampled. We found out that over 100 have mite counts of 0 to 5 mites, very, very low. And this was in September. Hives had very low mite counts. When I did the math, I realized that this represented 75% of our hives. This represented 25% of our hives, but there were 75% of the mites in that 25% of the hives. So these are your mite factories, okay? So having a few mite factories out here, the process of diffusion works only in the direction of from a high concentration to low concentration. So having mite-free colonies does not help the high mite colonies, but the high mite colonies are constantly diffusing mites out into low mite colonies. So your neighbors who are not treating and losing colonies every year and buying packages, they're just feeding mites into your hives. And we see this in every single yard. We get hundreds of these histograms. It's usually about 5% of the colonies are orders of magnitude higher in mites than the surrounding colonies. So by identifying them, you can help with your mite management. Okay, yeah. Oh, here it is. I forgot this. My son's finding it cost effective. So if you're not monitoring, we call that blind beekeeping. You don't know what's happening in that hive. So plan your strategy. You can use the model to figure out and choose what treatments you're going to do. So here's one where I took this same simulation. I did a Formic treatment here, a Thymol treatment here, and a oxalic acid or a hop guard, and just kept that mite count low throughout the year. Now, for beginning beekeepers, the number one mite management method is called wishful thinking. So just, I don't know how many bidders are here. Just skip over that one. Those who are thinking about doing, not treating some colonies and doing survival, you don't ever have to let a colony die to do selective breeding. It's done at the queen level. So that's why we treat our non-resistant breeders, so we can split them into nukes the next year and requeen them with resistant stock. You don't ever have to let a colony die to do a selective breeding program. And treatment-free is often used as an excuse for neglectful beekeeping. If you are doing beekeeping, that's animal husbandry, and you have an ethical responsibility to care for your livestock. Okay, if you want to be certified organic, it's in the manual. It says you have, if your animals have parasites, you have to control the parasites as an organic beekeeper. Now, the other thing was synthetic chemicals up here. This is where most countries jump to, and Australia right now, first thing they did, start handing out synthetic miticides. And I go, you guys have all these pure combs. You got like the only organic honey in the world coming out of here, and you're going to start using synthetic miticides first. So there's a big debate going on in Australia right now about that. But they're not sustainable because the mites develop resistance so easily to them. And the two main treatments the main treatment is amitraz, either in the legal or the unapproved method right now. The mites are developing resistance, and there's going to be and EPA started cracking down seriously this year. So most of the commercial industry is dependent upon unapproved use of amitraz products, and that might dry up. So I'm looking right now and working with the EPA and trying to help the beekeepers, because commercial industry is going to have a really bad problem. Yeah. The EPA. EPA is not going to do it, but it's up to your state regulatory agency. So we're going to have to, now California, in the law for California, the administrator has the option to exempt anything that's not have an unreasonable risk to the environment. So we're going to have to get, in California, we're going to probably have the California Beekeepers Association, which means that you're going to have be a member regulation saying there's EPA has decided that these are not of unreasonable risk to the environment. So you really don't have legal authority to enforce it. So, but that's what it's going to take. If you do want to use synthetic apistan, may work because nobody's been using it. So after several years, the mites that are resistant are they have a fitness cost, so they are outbred by the mice that are susceptible, and you could maybe use that in rotation once every few years. The problem with synthetics is they are lipophilic chemicals, which means they dissolve into the beeswax and they contaminate the combs permanently. So most commercial beekeepers have contaminated the beeswax supply for the United States. We have, my operation, we probably have some of the purest beeswax anywhere because we don't use any synthetic miticides. And fluvalinate lasted about 6 years before they developed resistance. Coumaphos about 3 years. Amitraz been going for about 20 years, and now we're starting to see some serious resistance. Dr. Frank Rinkovich is writing about that. Some of the mites now are 20 times more resistant than the naive mites that have not been exposed to it. So these biopesticides are likely more sustainable, and this is what I'm trying to work with the EPA, but working with the EPA is, I'm finding out, is really, really tough. They talk to you really sweet, but then their lawyers get out there. So one is HopGuard, the hops beta acids, and it's a brown sticky liquid, a little pricey, but it works very well when there's no brood. Can be used during the summer when there's brood, but it takes at least 2 treatments of that. Can be used when the honey supers are on, and there's times when we may use that in our operation. The Thymol and the other essential oils, I'm testing. We did experiments all last summer with other essential oils. We're still following up, but the one that works for sure is the Thymol. Various application methods of that. We've used the ApiGuard treatment for many years after we pull our honey in August. Yeah. So she asked, have you ever cut the herb yourself, put the thyme in the hives? I have not done that simply because the math doesn't work. There's not enough Thymol in the herb, right? Yeah. Okay, ApiGuard is the gel. Yeah. Oh, wait, you mean yeah, it's called Apilife Var. Yeah. You know what? It has a bunch of eucalyptol in it and menthol, which the bees don't like. And the colonies roar really loud. So it's so disruptive to the colonies. I didn't like it. We now have a new method of applying. I don't know if I have it in here. Oh, yeah. So I just published this blocks right here of 21 days under a rim in hot weather, and the colonies rear brood continuously. Almost 100% removal of mites works really, really well. Okay, but we're able to put by putting in a thicker block, we can extend the release. So instead of the 12-gram dose, normally the maximum you can put in, we put 40 grams on at one time, and the colonies love it. One of my assistants now, I'm trying to get her to start a business on aromatherapy product for bees, not for pesticidal use. Okay, so we're setting up, actually, I worked on it yesterday. I have a distillation apparatus so I can recover the alcohol. So we're going to try to start mass producing these. Okay, but it's, the thing is, there It's just no financial incentive once one's on the market for somebody else to go through the hassle and the cost with EPA. So there's no competition, so the price stays high. So I'm trying to get EPA. We're moving right now to see if we can get in the farm bill to add the Thymol, oxalic, and formic acid to the minimal risk list, which means that anybody could use it without registration with the EPA. Yeah. No, that's too thin. The half-inch acoustic soundboard, it was what I found, works really well. Half-inch acoustic soundboard. But go to my website, read the actual article. Okay? Yeah. This is Thymol. Thymol, right? And then now we're going to the acids. You have formic acid and oxalic. Formic is vaporizing at room temperature. Oxalic's not. Formic acid, that's the smell of carpenter ants. It'll make your lungs choke up, your eyes burn. It's the only treatment that can penetrate the cappings and kill the mites that are on the pupae under the cappings. But you have to have a fairly high dose. And something it does, I don't know if it cleans the combs or what, sterilize them, but it gives colonies a fresh start with a beautiful brood pattern. The downside is in hot weather, it can cause actual death due to the toxic action on some queens, or cause their workers to ball the queen and kill their queen. So I just published a couple of articles on that where the workers themselves kill the queen. So you can, with the only registered treatment on the market is the Mite Quick Strip and Formic Pro, which are essentially the same as far as in the hives. You can either put one strip in, repeat it at 10 days, or 2 strips. And let me see if I get the tip in here. Oh, I didn't put it in. Damn. Okay. To avoid queen kill in hot weather, when you unwrap the strip, you simply take the wrapper and put it over the top of the strip, or a piece of plastic or tinfoil or something. And that eliminates queen kill. It slows down that first day flash of the formic coming off. So we've tested that, and that eliminates the queen because we apply this, in 95-degree weather, and that eliminates the queen kill. And low temp is not necessary. The thing is, there's lots of different ways to apply formic acid, and I'm trying to, if we can just get EPA to put it on the minimal risk list, then we could bring these other application methods from all over the world. This method right here was the original method, the Mite 2 pad by Not Apiary Products. It's superior to the quick strips. They went to a less efficacious and hard and more dangerous product because they didn't want to put the rim. So these are we actually have a ton of these that we recycle, we recharge. Yeah. Then oxalic acid. Californians, we all grew up sucking on sour grass, which is buttercup oxalis. I showed you the drill method. Go to Scientific Beekeeping, and I now have updated this to use glycerin rather than sugar, a 5% solution of glycerin. So go look up oxalic acid treatment table, and the formulation we're using now is there. Hang on. Because I'm using it under experimental use permit. I have a pesticide research authorization. There is no legal use of oxalic acid for mite control in the state of California. Okay. You can use it for bleaching your top bars or for any other purpose, but if your intent is to control Varroa, that's a pesticidal use, and that in the state of California. No problem with the queens. I know that from my authorized research. Okay. And what we do for the dribble method with our research is we use a garden sprayer to put it on. But for the hobbyists, those wash bottles were great. And we do our early winter cleanup. For us, just before Christmas time. Now, visiting other countries, okay, so I've been in a number of foreign countries this last year, and in Europe now, Western Europe, no synthetic miticides work anymore. Mites are resistant, so they're all having to learn how to use oxalic acid and formic acid. So what they're doing is they're doing induced brood breaks. So many of them are locating every queen in every hive in the wintertime and in the summertime, caging her for 3 weeks to a month, using oxalic acid dribble and then releasing the queen, okay? Because nothing else works out there. So they are very much interested in selective breeding, and they're stuck at the same thing. The regulatory agencies aren't allowing enough uses of these natural treatments. So it's very frustrating worldwide. You can also use these queen excluder division boards, which we use for queen rearing, and you just simply confine the queen. Start on Saturday, confine the queen between two of these division boards, and 2 Saturdays later, release the queen out to the other combs, let her lay again, and then the next Saturday you pull that comb out, freeze it or let it chill, and dribble the colony with oxalic acid. So you get a very good mite control, which is simply confine the queen for only 2 weeks is all it takes. And then the other new idea is these oxalic glycerin strips, which are now registered, not in California yet, but they have recently been registered. So you may have one of these on the market. And this is widely used in New Zealand and South American countries, and they work well. I've also done lots of research by putting it on various matrices, and you can go to my website to see that detail. I'm not going to give you details verbally. It's all published out there. Works well. I would love to see somebody register this in the state of California, and it can be put on during the honey flow. We've had it tested, does not go into the honey, and works beautifully in hives. It's a long-term treatment. It takes about 2 months, 60 to 70 days to really get full efficacy. And if you ask me afterwards, I'll maybe tell you some of the stuff about that. And I get feedback from beekeepers worldwide. I get texts all over the place with pictures like this saying, "Oh man, those oxalic acid sponges just work so well. Huge honey crops, beautiful brood." Always, you're working with the acids. Keep a jug of baking soda in water. So 10 heaping tablespoons of baking soda in water. Any acid on your fingers or clothing or hive tool or smoker, just rinse it off. It'll bubble up on your fingers. That means it neutralize it instantly. We taste our fingers constantly. Fingers taste sour, they got acid on them. So don't rub your eyes, don't take a leak until you get the acid off your fingertips. That's just a suggestion, okay? Oxalic acid vaporization, very, very popular in some areas of the country. It is quick, but you do not want to inhale the vapors. I'll tell you right now, it's really, really painful. It feels like you're going to cough your life out. It is efficacious. There's no brood, but it takes multiple treatments if you have brood in the colony. We've tried it. We're not crazy about it. So understand the limitations of each treatment. And I put this on my website, First Year of Beekeeping. It shows you, based upon what the colony is doing at any time, which of the different treatments are most efficacious based upon the weather and the condition of the colony. And you can plan your own strategy. Selective breeding program for Varroa mites that are resistant to that treatment. And beekeepers have proven over and over again they're the best Varroa breeders you'll ever see. They have bred Varroa to be resistant to almost everything we've thrown at them. Okay, so rotate your treatments. Sir. It will be difficult, but I would never bet against evolution. Okay. What we do for us, we do a Formic treatment if necessary, early on, like going to almonds. We split our colonies to the oxalic acid dribble, and then we either put on extended oxalic through the honey flow, and if not, we do a Formic treatment about July 1st. We do a Thymol cleanup middle of August, and then dribble here. We've used this for 20-some years, and we don't lose colonies to Varroa. That springtime brood break is a key thing for us. And that's it. Yeah.
Notice the difference overwintering with supers, without supers. The supers affect Varroa growth at all.
Well, over winter, if there's no brood, there's no Varroa growth. There is a difference wintering with supers because you get moisture buildup with supers, so that's independent of Varroa. I'm not understanding. Supers have nothing to do with Varroa growth. Varroas only can grow in brood. Having supers on doesn't affect the brood. Yeah. I'm not sure. The beekeepers who pollinate sunflowers still have Varroa issues. So just like the people say, well, thyme, can we plant some thyme plants in the garden? Yeah. So in areas of France and Italy, entire hillsides are solid covered with thyme, and they produce thyme honey, and their colonies die from Varroa. Okay, so planting a couple of plants, even planting 1,000 acres is not going to help you. Okay? Yeah, you can love the flowers. Again, what's your joy? if your joy is controlling mice, then it's not planting. Yeah. So I did read something about sunflower, but I don't remember that it was related to Varroa. It's something else I thought. So I'm not sure. Yeah. Yes, sir. When you say more frequently than what? No. No, queens have always lived. This whole thing about queens dying rapidly. No, if you go back to the literature, a queen, if they have several months of brood rearing, like somewhere in the lower latitudes, year and a half, and they run out of sperm and they get superseded. So our queens almost all, if we don't replace them, they will come August, September, almost everyone gets superseded naturally by their own daughters. So that's normal when a queen runs out of sperm. If you have, like, if you buy California queens right now, you're going to see some that get superseded by the bees because it's been lousy mating weather. So if you want to buy queens from a commercial queen producer, look at their location, look at the weather history for 2 or 3 weeks before that, and that'll tell you a lot about how good a queen you're going to get. Okay. Yeah. So right now we had terrible mating weather up in our elevation, and we're seeing the queens may be laying, but they do get superseded. Yeah. Well, hang on a second. I'm sorry, we don't want to interrupt you. You guys done? Okay, seeing that colonies used to collapse over winter and now during swarm season, we have not noticed that. Normally, if they make it through the winter, that means the brood level was low enough that we would not expect a collapse during the springtime. And is this more than one colony? And tell me the symptoms. Tell me the symptoms of what you see. Do you see dead bees? Okay, that's not a collapse. That's just unsuccessful mating of the virgin queen. That's normal. Okay. The reason I was asking, I'm getting some reports of chronic bee paralysis virus, where you suddenly see all the bees just drop to the bottom board like an inch layer, and they're all twitching. That's chronic bee paralysis virus. Looks like a pesticide kill, but it's not pesticides. Yeah. No, you can breed for resistance to swarming. Some stocks of bees tend to swarm more than others, but I haven't. That's nothing I've seen or heard anything about. Other questions? All right, guys. Okay, I wish you the best with bees.